soar, use your own AI, we'll explore. Help the future hand in hand in this tech-driven wonderland.
Okay, hello everyone. Welcome to this week's AI Office Hours. We have ZetaBlock co-founders today. Very exciting. I'll let you guys introduce yourself, and then we'll dive in what you're working on as well as what's happening overall.
Awesome. Hey guys, nice meeting you. Hey Illia and Alex, great seeing you guys again. And my name is Chi. I'm the co-founder and CEO of ZetaBlock. So a little bit about myself. Before ZetaBlock, I used to lead product management at a Web2 AI company called Databricks. And then before that, I did my PhD from UC Berkeley, more at that time focused on machine learning and causal inference. So right now it's probably called expandable AI. And right after my graduation, actually, the first startup that I was a founding member at was a automated machine learning platform company. So have been spending the last decade in the AI and big data space. So nice meeting you guys.
Hey, Illia and Alex, great to see you guys again. Hi folks. So my name is Scott. I'm co-founder and CTO of ZetaBlock. Before this startup, I found a streaming DB company, and before that, I worked at Uber before. So I built a skill AI inside Uber, like human in the loop data labeling platform at Uber, and then it grew actually from like more than 10 use case actually with 200 full-time employee working on it, labeling all the things for the data and then for the AI use case. And before that, I worked at Salesforce on Salesforce Einstein Analytic Cloud. When I was one of the founding engineer. I graduated from UIUC graduate school. Yeah, that's my background.
Awesome. Well, great to see you here and kind of introduce you to the viewership of AI Office Hours. Let's give us a quick overview of what ZetaBlocks is and what problems are trying to solve.
Awesome. So ZetaBlock is, we call ourselves a decentralized data-centric model development platform for trustless and open AI development. So what does that mean is basically we enable model developers to collaboratively curate, manage, and monetize data and AI models with robust governance and ownership principles. And the ultimate goal here is to foster a open and accessible ecosystem of data sets and models. So more specifically, basically, we allow data curators to share and monetize the data sets for AI access efficiently, and also model developers can build and share models with those usage-based rewards, and also like the model users, such as like the app developers, or even let's say the data providers can access and deploy high-quality models in their preferred environment.
Awesome. Yeah, I mean, go ahead, Alex.
No. I just wanted to mention that it's something that I think Illia and I were discussing something along these lines. I think like as far back as a couple of years. So it's exciting to see that materializing.
That's awesome.
What I mean, to make it spicy, what do you think would be the like your competitive advantage to win here?
Yeah, that's a very good question. So apparently there's a lot of companies and platforms in Web2, such as Databricks or Anyscale or Together AI are building robust platforms for model development and data processing for model development. But the goal here, or like the differentiation we think we can leverage blockchain and crypto to do, is actually bring the better provenance tracking guarantee and verification into the process. And the reason why we think this is very important is we believe in the future there's going to be billions of customized models actually built on top of, let's say, foundation models to empower the business use cases or business process, or even like your daily operations work. And in that way, in order for you to trust models and agents to run the job for you as a company, as a person, you want to make sure one, the contribution you made into the process actually can be tracked, and also like get the loyalties and contribution back to what the percentage of contribution you made in the process. And second of all, very importantly, how you can have a more systematic way to guarantee that this process is have like a high integrity, is not like being poisoned or being tempered with like bad behavior, or like it's just let's say bad data. By the way, we can dive into that more because we're a data-centric platform. But overall, we believe that with the future that's going to be run by billions of models and agents, it's super important to have a platform or solution to guarantee the provenance and verification of the process.
So because Illia and I have been thinking of it as far back as I think it was like 2022. There is a set of challenges which I think are kind of interesting here, and they're not specific to this particular use case, but this particular use case I think is particularly dependent on those challenges being solved, right? So one of them, and I wonder to hear, like I would like to hear if you guys thought of them and if you have interesting solutions. Or so one of them is that data has this property that it's very easy to copy it and sort of forget about attribution, right? So there's like two sides of the problem here, right? So if there's a model, if there's a custom-made model on a particular data set, from one side we want to be sure that it's what it is promised to be, right? And from the other side we want to be sure that as the person who develops the model, we want to be sure that nobody just copy paste, like the first person who paid us and got the weights doesn't copy it and distribute it further. So I'm curious if you thought about it, or if it's more of
This is actually a common question asked from the data contributor in our platform. I think that we actually building two ways to address it. First is that in order to make sure guarantee people cannot download the whole data. In this case, for example, when you if you think about the machine learning or AI builder experience, most of the time you actually don't need the whole data to do the initial model delivery, like the initial model building. You just need to sample sample some data and then make sure it's actually fitting to one machine. In this case, you can speed up the development. You can think about the structural data, how you structure your AI model building, and then how you set your hyperparameter with the sample data and build some prototype and set up some basic benchmark. In this case, you actually don't need to download the whole data. But when you actually say, hey, this looks good, I want to go production. In this case, you say, hey, let's actually retrain the model, use the same structure with similar hyperparameter, maybe try to tune a little bit for hyperparameter, but with full data set. In this case, you need the full data. So what we do is that we actually don't allow you, in this case, to guarantee this is actually a data contributor setting as well. We don't actually allow them to download model builder, download all the data. But at the time when they actually want to roll this in production and say, hey, now you can use the pipeline, run on the platform. In this case, the model builder cannot steal all the data and then deliver the end model. In this way, actually, the model actually preserve all the lineage. So you know which base model is built on top of, which data set is built on top of, but you also don't reveal the whole data set. Additionally, I think there is a lot of research at fingerprint to the data set as well. In this case, just in case someone steal your data set, you want to add some fingerprint to the data set and then detect if my data set has been stolen and use Outsphere in other models. But it has some unwanted impact because all the model weights are interconnected. I think Illia talk about this question. If there is a magical function G, like you can have some base model, apply new data set, produce a model, and then just add additional magic knowledge to the new data set without impact the original weights. But apparently they don't exist. So for this type of research, they say, hey, how can I have minimum impact? Just add a fingerprint for my data set, and then but also reserve the original weights for the data set. It's still a research question, research problem, but we're also doing some research in this part as well.
So if I heard it right, just to confirm, so effectively, when I'm ready to train on the whole data set, that model will be trained on your hardware, right? Yeah.
That's right. That's right. So I think in the future there are also some research topic, like use TEE, like trusted, execution environment, like beyond our hardware. But for now, I think that this hardware is because we want to make sure the data set contributor are confident they can put the data set in our environment without worrying their data set is downloaded and still for free in this case.
Yeah. So I think that also creates interesting challenges, right? Because like let's say, I mean, not every data set is 15 trillion tokens, right? So if it's a particular custom-made data set, I guess a problem there is that the model size can easily be bigger than the size of the data set, right? So like let's say it's a 7 TB model that I'm fine-tuning. That's like a 140 gigabyte blob of data, right? So if the whole data set is on the order of 20 gigabytes, then I can like my model training loop can be a trickily manufactured code that encodes the whole data set into the model. So when I then load the weights, I can
it's
easily
like recall the whole data set instead of like, this is actually a very interesting problem. If you look at the whole English Wikipedia is 20 gigabytes. That's why probably you mentioned like 20 gigabytes. And this actually grow very slowly. Like 12 years ago when I was in graduate school, that is only like 15 gigabytes. That's actually indeed a problem. In this case, is instead of like sampling data, you may want to download the whole data. In this case, I guess we can just use a post forensic. In this case, if you actually use my data, I need to actually get your, I need to get my money back. In this case, So that's probably the sampling part may not solve this problem, magically. In this case, and also for the, I think for the. For the company actually can afford it, a 40 B parameter or 400 B parameter. That's probably, they probably have money to purchase the data. For now, from what we learned, data purchase is actually not the biggest pain point. Performance is still the biggest pain point for the model builder and the model user.
The performance of like fine tuning or of inference, or of the model, or you mean like performance in terms of like
performance of model.
I see.
Performance of models. So I think most of the model can achieve like if it do a lot of tons work, they can achieve like roughly a 90% of performance. But it's actually don't meet the expectation from the customer. Most of the enterprise or customer expect like 99, 98, maybe even like 99.9. There is still like a 5 to 10% gap between the model provider and the model user.
Yeah, I think that's a challenge in general of this kind of more static approach where you expect there's a data set, you train on it and then it works, right? Like the reality is you want to create a feedback loop with your product in such a way that you keep actually getting improvements, you keep getting new examples, and they go back into your model as well. And so you like maybe start at like 80, 90%, but then able to improve over time as you actually like find those cases when the model is not doing well, and then that one way or another get human feedback to improve it.
Yeah, Illia, I definitely like your word description, like the feedback loop, because this is actually the key component when we actually build AI, build AI model and the data. Not only we need a feedback loop in the AI building process, but we also need a feedback loop to actually find particular missing data. It could be like data missing labels, data missing, like this particular data set miss a lot of, more sampling, and then go, deliver this data to collect more human feedback. And then that's actually a constant issue. Like for several use cases, I built Uber. This is actually a constant issue. Like even for Gen AI, we learn like currently a lot of the video, text to video company, they're currently missing the Hollywood standard studio, the audio, video data. That's actually, that's also an issue as well. In this case, like they need high quality data with high quality studio with great data with labeling. Like some people think, from my past experience, some people always think like a data labeling is like a one shot, but it's actually not. It's actually multiple shot. In order to achieve the best model, it's actually multiple shot. You sometimes first need some sampling data, and then you sometimes taxonomy to actually classify data, label data, but almost always, you're missing some data. You need to go back and labeling the data again for a particular subcategory of the problem. So that's why it's the data iteration and model iteration is like, interact with each other much more often. Yeah.
Actually, in this case, Illia, I have a question for you, because I know that one of the original, I would say, things that Near build was a more decentralized data labeling or annotation platform. And at that time, so right now we're also working with some of the companies like that. So one thing I'm curious about is how do you think about the data quality control in the process? Because one of the biggest challenge for us to run into, even when we are handling the enterprise grade data sets, that's just come from the entire data set come from one enterprise entity. There's still tons of like data quality issues and process we have to go through to overcome it.
I'll actually let Alex respond as he's the expert on this.
Most of the experiments we did with the data labeling, I was involved one way or another, and I'm running right now the de facto platform we have, so the problem, like the high level problem, right? You label a very large set of data, right? So you have a lot of people contributing, and incentives are severely misaligned, right? Because people have no incentive to provide high quality work. What people have is an incentive to make money, right? And so you need to design a system in which those correlate as much as possible, right? So that you make as much money as possible when you provide the highest quality of work. And that's very hard to do for reasons that, like if you need to annotate, tens of thousands of samples, you're not reviewing all of them, right? That is out of question, right? Like you can at best review a sample of, like, let's say 100, right? So if you look at a sample and it's bad, not much you can do, right? You cannot not pay all of them. And we've been playing a lot with different systems where you would have, like effectively, it all boils down to the fact that you need to make people review work of each other. That's the only scalable way. But a lot of naive approaches collapse. So like, like the Nash equilibrium, or so sort of like the point of convergence would always be where people do the smallest amount of work for the best outcome, right? So like in the simplest case, if there's not sufficient punishment for the incorrect review, they will be just like accepting everything they see, because why not? Like obviously 80% of work will be good, so I will be right eight times out of 10. So like if the system sufficiently calibrated for me to be punished sufficiently badly in those 20% that I don't do that, right? And we iterated over like 4 or 5 systems over the years. I think the current one we have has been relatively consistent. We might publish an overview of how it works, and effectively, like on the very high level, it all boils down to the fact that you do need honeypots. Without honeypots, it just doesn't work, right? So we try to do fluent system. Fluent system is where after every review there's a say 50% chance for another review. So then on average you have 2 reviews. But after after you review the work, there's a chance, and the chance is always 50%, no matter how deep you are into the review process, that someone will catch you. So that just doesn't work. People still converge to always accepting. Right. So, but honeypots work very well. Like if you have a honeypot that penalizes you very heavily, you will be paying attention. And you need you need some sort of a system of reporting. Like effectively, some people will always be misbehaving. People will be trying to break the system, and you just want to catch them quickly and get rid of them. And in the early versions, we were hiring people to review reports. Like we would have, like a set of moderators who would be reviewing them. and eventually we got to a system where people review reports on each other, and it works relatively well. Like details matter, and we will publish them eventually. But like if you build those components, it becomes like the average quality is pretty good. We right now we're annotating on the order of 2,000 data points every day, which I don't know if it's a lot or not, but the quality remains relatively consistent.
That's very cool. And I'm curious, like, is there any particular type verticals or use cases that you guys are focusing on for those data annotation, where it's like a very broad across different industries?
So everything we do right now. So first of all, right now it only works for us. We never until like January of this year, it was not working that well. I think so. It was not ready to be, open to everybody. And right now we just didn't have resources yet to expose the API for people to build their own annotation sets. But everything we annotate is either high school math or programming. It's all for everything goes towards the goal of AI developer.
Ah, that's very cool. Oh yes, I think I heard about something about that project before. Looking forward to that.
Yeah, it's pretty much the original near AI kind of stepping stones toward AGI. Is that we believe AI developers pretty much functionally enables kind of next step, but in turn also produces an extremely valuable artifact, which is allowing everyone to become software engineer and build software, and in turn change how we interact with computing.
That's cool. And yeah, in that case, I'm curious, like, did you guys also benchmark with, like, say, Costraw, which Mistral launched a few months before, and also Davin type of models for like AI developers as well?
So the actual agent, I think our current agent is inferior to Devon, partially because there was much less work put into it as of yet. Partially because Devon is based on so everything we build right now we based fully of open source models and data, right? So I mean Devon is powered. It was powered by GPT-4, I believe. I don't know what it is today, but it's a more capable model. Yeah, I think like once we, it will be interesting to see the benchmarks later when we have a more developed agent. Like the entire near AI effort right now is how much 6 months old at best, and we did do a little bit of benchmarks. So one of the particular data sets we annotate right now is competitive programming, where people solve problems, explaining step-by-step solution, and we did some benchmarks on that, and that data set clearly improves the capability of the model, and yeah. So in that particular direction, we're working with one of the big problem archives. So there's a good chance we will be publishing both a data set and a benchmark in the foreseeable future, specifically for competitive programming.
That's very cool.
So one question I would like to ask Illia and Alex here is that what's your opinion on the future? Do you think it will be a handful of foundation model, or do you think it's going to be like a AlexNet and neural network? The model parameter will go up first, and then you have like a more and more smaller model, like a domain specific smaller model. Like, what's your opinion on this? What's the future of the AI?
It's very hard to predict. Let's begin with that, right? So probability of me or Ilya being correct here is give or take 50%. so it's at best.
We should give two different answers, and then
yes, yeah, it's not. So in my case, it's less of a prediction, more of a belief. So I think that the tier 1 models will always be. I think, and I don't think that's a popular opinion, but I think tier 1 models will always be better at any downstream task than any fine-tuned smaller model. But assuming open source models remain behind, right? Which we would prefer not to be the case. But assuming that is still the case, I think like for particular use cases, it will always be beneficial to have a LoRa put on top of the model for your particular use case. Like that will always be superior. Assuming like your use case is not something that hundreds of thousands of people did on the internet and the model is already good. So like like for simple autocomplete, I don't think any amount of fine tuning will make model much better because it's in GitHub with such a vast amount of code, right? But if it's like a good example would be formal verification, like Lean. Lean on the internet exists, but very little, right? So if you manage to get your hands on a massive data set, like that LoRa will be superior, obviously, to a base model.
Well, I think there's another dimension, which is when you get things into production, if you can compress the model size while maintaining quality for your use case, that's just more economical. And so presumably you don't need a model that can recite every poem and know all the news if you're trying to indeed like suggest code complete. And so you can distill kind of bigger model into a smaller model that's specialized in set of skill sets that you need. And so that's just pure economics talking, not kind of capabilities. That doesn't mean that like the big model is not as good at that thing. It just means like you don't want to spend 100 or 1000x power and compute on doing the work that especially if you have a big audience to do it. But I think if we're talking about more kind of generic assistant, that's where indeed probably bigger models with a complex system around them, right, for memory, fresh data, and all kinds of other things. It's unclear. I mean, pretty much there's like two designs, or there's probably a design spectrum, right? There's like one giant model run with like a whole host of services around it that is your personal assistant. I have a model on my device that has access to all my data, and so it's actually better at contextual predictions because I trust it's not going to leak all my data to some other company. And then you have like a spectrum of other things, which is like, I have a bunch of agents which are like all specialized in skills, and you can route between them. So like kind of mixture of agent step approach. And so depending on kind of, I think like, OpenAI, Claude are betting on this like one giant model, bunch of services around. There's a whole host of companies that are trying to go after this, just on device edge compute, including Apple, because it's just like such a cleaner design. It's a truly distributed, decentralized by the fact that you don't have a central model system, and it's so much cleaner with personal data, right? Like the amount of personal data and kind of leakage that happens with OpenAI, right? I mean, is massive. And then everything in between is where I think the current design space is. Like, can we build an interesting distributed models? Can we build, set of agents that are able to do different skills, but then combine them together? That's kind of where, potential for innovation is. But I think one way or another, it will be a combination of all of those things.
Yeah, actually, what you mentioned just reminded one of the Web2 companies that we're working very closely with. They're like very conservative and regulated industry. So for them, one of the case is they have to compress actually a big model, or even like just to train a small edge model from scratch, because when people download their app, they have to basically have the small model download from the app with the app together, because they have to process the user information locally without sending that to their central data centers. And to them, that is like a more from regulator perspective, that they know if they they collect those user information and process it in their centralized on-cloud data center, that may cause potential legal issue for them in the future. So in that case, they have to rely on more like a mobile-based edge model for that.
Yeah, I mean, I think like we can imagine, given where all the regulations are going, this is actually going to become more and more pervasive, because like the reality is user data in centralized companies is like a toxic material, right? You need to like handle it with care, make sure it doesn't, leak anywhere. And when it does, like if as soon as you like have logs or anything, that like now you need to deal with that, and you potentially have a fine now, because if a European asks you to delete it, or Californian asks you to delete it, and you did delete it everywhere, right, you're liable. So I think that's what I'm saying. The design of shipping model to the data is just such a cleaner design. Now the question is, how capable are these models, and how powerful those devices are. And we actually reviewed last week the BitNet, a kind of either 1 bit or 1.58 bits model that is way more energy efficient, right, and compact when you're actually doing calculations. And so you can run it on mobile devices a lot more effectively. So I think those kind of innovations are also very interesting, as well as hardware innovation that will make local devices more powerful. But I think the other one is like, can we have like homomorphically encrypted or partially encrypted kind of evaluation that can happen? There's people doing secure enclaves in GPUs as well, right? So potentially the evaluation, the inference is happening encrypted in secure enclave, and then you maybe have like a RAG that's homomorphic, like fully homomorphic encryption, and you fetch from that. This is something that we kind of are researching right now as part of the user-owned AI architecture. So all of this like components, as you kind of build that system, yeah, you can kind of imagine all those components coming together.
That makes sense. Actually, since you mentioned the user-owned AI, so for the user, like who contributed to this AI process, what is the ultimate goal here for you guys? Like give the rewards back to them fairly, or like what is the the vision here?
I mean, the broader vision of user-owned AI is actually, and in general, is kind of this property of sovereignty and like ability to own your own data, assets, and power of choice, right? And this is kind of the broader vision of NEAR. And so the point here is not to like, hey, we reward you for specifically this example, is this training data piece that you passed somewhere, but actually more about the models are optimized for success of this individual, right? For their financial well-being, for their kind of mental well-being as well. And this is kind of to contrast with kind of corporate-owned AI, where it's optimized for success of that company, right? For how much money that company can make. And so really it's kind of a piece of this broader user-owned internet vision that we're building at NEAR. That blockchain is part for the assets, AI is part for kind of data and intelligence, ability to choose things individually. And then as you kind of see this projection, the reality is like the way we interact with computing will change, right? As soon as you have an ability to build software on the fly, you don't actually need applications anymore. Your operating system will be a lot more predicting what you want and generating potentially UX on the fly. And we see a lot of examples now, right, of this actually happening, where people like build new applications, right, within front end of the application pretty quickly. We also kind of have some demos for that. And then beyond that, you have AI agents and kind of AI services that are actually able to complete functions. And so how do you pay them? How do you interact with them? Well, obviously they're going to be having a blockchain address, and you'll be able to pay them and call kind of this APIs, these agents with money attached already on these transactions, and have some set of crypto economic incentives for them to respond to you. So all of these pieces are kind of like linking things together into this vision. So Now the transformation from where we are now, which is like the application world, will be a journey, but that's kind of, this transformation is happening.
I do agree. Yeah, I do agree with you, Illia. I think now because the trending for this AI, and also how easier it's actually train a new AI model, like fine tune or train an AI model compared to like 5 or 6 years ago. Like at Uber, I supervise and help with 2 AI model building. One of them actually collision detection. For example, if I take Uber today from San Mateo to San Francisco, if I have a car collision, Uber will push notification to me almost immediately. This very simple feature actually requires more than 10, like 2 machine learning engineer, 1 data scientist, and then 3 like a software engineer built for 12 to 18 months to deploy in production. Like this simple model, just say, is there a car collision costs Uber like roughly 3 million to deployment, develop, and then more than like 5 million to maintain. But now with the foundation model and this new generative AI, you can build your agent, like an agent represents you less than like $100. You can just pull all your data and then fit into the agent, maybe do some labeling, and then you can build like an AI agent like within $100. This happens not only for this particular use case, but also with the recommendation system. Like previously, only very few companies can do the recommendation system because it requires tons of experience, a lot of data engineering, processing, and then also production grade this maintenance. But now I think it's much easier for all kinds of AI models because now you can just sit on top of foundational model. So I think it's because the cost for build a model has been lower, like by like 3 or 4, even 5 level of magnitude. It definitely makes this possible. But there's still a lot of hurdles there. For example, how do you process the data? I think one thing people actually always overlook is the complexity for data engineering. How do you actually massage data, process the data, clean the data, and then that's actually very hard. And that's actually in this case case by case and use case by use case different.
I mean, I totally agree. I mean, data in general for any machine learning, data engineering has been 80% of work usually. But I would also say that with the advancements in, again, what we're doing with the ad developer and other folks doing, we're actually going to see us all using AI to do data processing as well faster, right? And so similarly, we already see like people starting to build agents by using AI agent, right? So like we'll start to see that acceleration happening. And also like because of like how higher level semantic understanding, right, these LLMs have, you don't need to do the same level of processing always, right, that you needed before, where you kind of needed to like munch data to the level. Like you can use the agent itself to like, okay, read this data and find all the like outliers and decide what are the potential like examples or like fill in the gaps, etc. I have a friend who's like, they literally built like AI analyst like agent pretty much that sits on top of their data like ETL pipelines and everything and fills in all those gaps.
I completely agree with you. I think based on one of the biggest foundation model company, the first step to the data clean is that they actually build a smaller model to do, hey, is this good quality data or is not good quality data, and then filtering data and filter the outliers. And also for the problem I was solving like 6 years ago at Uber, one of the most important issues is that we need to filter all these very serious incidents from this billions of model. Uber has a billions of tickets, like security tickets, like safety tickets. It could be like dangerous driving, this type of tickets. But some of the tickets are very serious, like it could be have like car robbery, and could be like this very serious incidents. And then at that time, we actually need to build a class taxonomy, like this heuristic taxonomy to address this. But now I think that I imagine probably the first step is that you can build a very simple model and then trying to figure out the different category, like categorize the tickets as a first pass, and then use the data to build a model, a more advanced model to actually address all the tickets and labeling all the tickets.
Yeah, to add on top of that, actually, what Ilya, you mentioned two things really is interesting here. One is so one of my friends, he worked at right now as one of the biggest competitors to NVIDIA, and when they do the production use cases that they're trying to help their enterprise customers adopt the chips and also like the end-to-end solutions they build for them. One common use cases they see is actually their enterprise customers trying to build basically AI agent for automated ETL pipeline building. So data engineering in this case is right now in a lot of enterprise trying to using Gen AI to automate or like semi-automate that. So that's just definitely something we have observed in the industry happening. And second of all, you mentioned the user-owned AI. Actually, what we observed and also worked with Web2 companies, we observed that this user or like the way for the companies it's not only like the individual users trying to have like the data sovereignty or like data provenance and have a better monetization on the data. It's also I think some of the enterprise or businesses who are, let's say, not very technical in more, let's say, traditional or like less just the technical industries. They also sit on top of like a very high quality and useful data sets, especially on the sort of like a new multimodality data set, like audio, video data. And for those people, they're also trying to figure out like how to make the data more monetizable and useful. And one thing we see here is if you are not, let's say, a big company like a Google or Meta or like OpenAI, you have like tons of resources to go acquire and purchase data sets from other companies. In that way, if you're a smaller model company who just raise, let's say, a couple of millions or even like just to say low 8-figure million to build a specialized foundation model or like an AI model for something, those people have challenges accessing the data sets that is unique or useful for the model they're building. And in that way, one thing we think like, or we observe and try to use blockchain to solve is how you can align the data owners or like the data providers, even as a business, not even just at an individual level, as a business. And also like the model builders who is seeking for high quality, relevant data for building the model. And each of them have the special resources that the other side is lack of, and that they're trying to, for example, data providers may be wanting to provide the data for free to the model builders in that sense to build the model. But in return, what they want is also part of the revenue generated from the model in the future that can go back to them. And also when the model builder use their model to use their data to build the model, they can become the model user as well. So basically the data provider and the model user are essentially the same people, the same entity, the same business. So in that way, how we can align the incentive across that two entities, like the data provider and the model builder, is something that we think blockchain can be also very useful. So in that sense, it's also sort of like a user-owned AI, but it's instead of being individual user, it's like the business users.
Yeah, for sure. And I think, businesses and communities have the same need, kind of at the different scale. I always use this example that like Facebook Meta doesn't use Google services, like it doesn't use Google like apps. It actually uses Microsoft Stack Exchange and Outlook, which the first time I saw it was kind of shocking. But the reason why they're doing it is because compared to Google services, which are all on their backend, right, you can actually run your own Stack Exchange in-house and have.
It's just Exchange.
Exchange, yeah. So, but yeah, I mean, obviously they built their own for work tooling and messaging and everything in Facebook. But I think that's a general, like, the need for companies to actually have to own their data is there, and it's maybe even bigger than for individuals, kind of from a demand perspective. So I agree that there's like a big opportunity there.
Yeah.
For
and
users,
like
it's more like a values thing, right? For companies, it's actually like a business thing.
Yeah, and to your point, it's actually unsolved problem for like any data creators or owners at the moment, like how you can protect your data from not being, copied or used by other entities when you are trying to monetize it. Because the biggest worry to everybody right now is, like Alex asked in the very beginning, is if I sell this data once, how can I know that this data is still being protect, still being able to sell again? Maybe someone just copy it and use that in other places. And also another thing, really, when we start using the blockchain method, or like this crypto incentive alignments method to think about this way, is really for in the very beginning, the data owners trying to sell the data in the beginning, because that's the only way they can get the revenue. But if there's a way for them to get like sustainable return, sustainable revenue from the entities built on top of the data they provided, the raw data they provided, such as model, then that's become something even like more attractive to them. And also that's actually lower the entry barrier and the cost for the model builders in the beginning to build the model, because at the moment to acquire those data indeed is a very big barrier and cost to a lot of smaller model builder or independent research institute, which in that case is like blocking the like open AI ecosystems for those model buildings.
So by the way, interestingly, my original question was not about protecting data; it was about protecting models, right? So I was like a use case. I don't even know if that use case exists, right? But I find it interesting that in the world where we actually do care about, in the world where a lot of small models win one large model, I think model is a more interesting asset than a data set, right? Because data set is like selling fishing rods, and models are like selling fish. Like if I want to have lunch, I'm not going to go and buy a fishing rod. I'm going to buy fish, right? And models, like with the data set, I think your solution is, I don't know if it's the best solution, but it's definitely a viable solution, right? You just, if you want to use this data set, we're going to train model on our hardware, and we will do, whatever review necessary to make sure you're not trying to encode the data set into the, resulting artifact. But with the model, it's more interesting, right? Like I want to have a marketplace for models. How do I make sure that someone doesn't just, and it's a LoRa, right? It's a LoRa on top of 400 bits, tiny. Like how do I prevent someone just pasting it on paste bin, for everybody to enjoy?
Yeah, so I think there is some proven method and some method also in research for this. But again, like if you say, I think one of the method is that just add a fingerprint to the model. In this case, like if I answer this question, then you give me a particular. If I ask A, you're gonna give me B. Minimum question, meaningless answer, but it proves that this is actually my model, like in this case. Another thing is that I do think there is a lot of the model weight comparison in this case. Like you can compare like model weights and say, hey, this model more like a derivative of this model. Could be like direct copy of the model, but it could be like derived model based on this base model. I think that two way. But nowadays, actually, you cannot preventing people steal it first, but you can retrospectively find people and steal them, from this retrospectively. That's probably feasible. There's, again, there's like as Illia mentioned earlier, there is like a hardware guarantee, like an enclave in this case. But for now, the performance is still very far away in this case. I think the first two approach may be more feasible in the near future, I guess.
Yeah, but like of course, like the thing is that on the international scene, even if you find the person who stole your model, it's not always possible to go after them.
Yeah,
as many people from my motherland know. Yeah.
So in this case, actually stealing the model is no different than stealing, like download a movie, in this case, and then it's actually been a problem there for a while. And then, but if you look at the past 15 or 20 years, I think the IP stealing is actually become less and less in this case. For model, it's actually more interesting because it's the same selective variation of this. I think that's been a battle. We're battling for last 50 years, 100 years each.
Well, I think this is also about innovation in the way to interact, right? I think the subscription models, for example, changed like how we interact with content. That you don't buy individual CD of every or person you want to listen to, and same, you don't need to buy individual DVD to watch every movie. You can just watch and pay kind of a flat fee. And I think for the most part that model works. And so I think similar thing will need to happen here is yeah, maybe you can screen capture the weights and put it in pastebin, but if it's just a fixed fee you can pay and use every model, right, and it gets split between all the people who contributed models, I think that's just going to be more effective. I mean, that's also something we're exploring on our hub side as well. How can we just build a subscription model which then flows the revenue to all of the providers of data, of models, of other kind of contributions, because the reality is it's so hard to actually do proper attribution and kind of guard and control everything. And instead you just want to make experience to be better. And I think that's fundamentally what we're going after is we need to make experience better, make it more open such that more folks can contribute, and then through that build kind of innovate in business models as well to allow everyone to kind of capture a proportion of that revenue stream.
I completely agree with you, Illia. It's think similar to the movies. It's never about that particular definitely that's a core value, but it's also about experience. Similar with model, it's like a service. If you consider a guardrail, if you consider a rack building and the session, this surrounding services, I guess the ground, the space for the model stealing will be less and less. And in particular, unlike movie, the cost for calling a model will decrease dramatically over time as well.
Yeah, it just so Ilya would probably confirm that most of the piracy back in the day was primarily because it was much more convenient to watch a pirated movie than to find.
Yeah.
It was barely impossible to find a legal way to watch it. And it's actually back, in Russia, it's back to the same, right? Right now, you cannot watch a movie legally. The piracy is again at its highest. But yeah, I think if a model is relatively cheap, then you will have two competing costs: the cost of using model directly, or the cost of finding the model, right? Because it's not you spend your time and you're risking downloading some garbage. So I guess it's always depending on the. And I think for when we were discussing it with Ilya in terms of near license, it also may if it's an enterprise, if it's a company that uses your model, the legal risk of using a pirated version is worth dealing with it.
Yeah, exactly. Yeah, I mean, for any enterprise company side, and then for consumers, it's about making the experience so smooth that they don't want, if all of their data, personal data, etc., already linked in there, and it's not worse. Okay, you can do it yourself, and so yeah, I think there's ways to solve it through experience and business models.
That makes sense. And also agree on what you mentioned that in the beginning, it's like we take like baby steps to solve some piece of this tracking and provenance, and then make the, let's say, the provenance algorithms better to be able to identify which person, individual level, or like a data point level contribution to the model. But in the very beginning, like for example, when our users also ask like how, when their data has been used for the model building, how that's being track and guarantee the, basically give the loyalty back to the data owners. In the very beginning, we also know that it's very hard to solve the provenance like very accurately and the contribution very accurately. So in the beginning, it's also, we're proposing as more subscription based type of a method in the beginning, but things can be tracked on chain, and that's what already solve like partially of the trust issues in the process. And then gradually we can make the process more accurate and granular in terms of the contribution rewards accuracy. Yeah.
So we do firmly believe a better AI economy is the most important thing, because currently the most gap between AI go to mass adoption almost in every aspect, every field is accuracy of AI. That requires more and more, expertise, domain expertise in each domain for AI builder, plus more and more like a domain related specific data sets. And then without a better economic to better incentives them, it's probably going to take longer. Eventually we may get there. But if you say, hey, as an AI model builder, I can get paid for my model. As a data set contributor, I get paid for my data set, high quality data set. This probably can shorten, the mass adoption for the AI model for the human beings for 5 to 10 years. Like we actually spoke with a lot of the AI model builder. They built models, download like millions times over last month, and over like a tens of millions times over last 3 months. But they actually didn't get paid even for a penny in this case. So that's why I say it's actually think from the model builder perspective. They actually take a huge risk to do research for the model, because it's not cheap. If you look at like 800 GPU, it's roughly cost you $50 to train for 1 day, and then sometimes it gets to do a lot of trial and error to actually has a meaningful model. In this case, we definitely the world need a better AI economic to actually to give them more incentive, and also maybe even for crowdfunding them to build something cool in the beginning.
Yeah, I think there was an interesting idea somebody shared with me, which was, imagine instead of like starting a company, you actually start an agent, and agent is autonomous from the start. It launches its own token to fundraise, and uses this money to acquire some data and fine tune on this data, and then it uses this fine tuned model, and now it provides services and gets paid for doing that, and kind of pays back, or distributes revenue to the token holders. Right? It's like a fully autonomous company agent that like specialized on specific task, and is able to continuously potentially refine the model and kind of keep fine-tuning it as it goes.
I love this idea. What?
I was going to say that Sam Altman famously said that he hopes that OpenAI will enable the first single person $1 trillion company or something like this. I might be messing up the order of magnitude on both
One
sides.
person $1 trillion company. Yeah.
Yeah, but I think he like overestimated the number of people necessary by one.
Well, I think it's also, this also will mean there will be a lot of smaller, like this is that like mixture of agents system, right? Where you have just a lot of experts, agents, which are like specialized in specific skills or specific knowledge type or specific kind of type of function. It's similar to this kind of API land idea that people always imagine, that there will be like lots of APIs and you can pick from them. The problem in Web 2 has been that you never can rely on somebody else's API, because their company is going to close next year. And so as you're building kind of, any mesh you're building, they'll break it under you. So you kind of need some guarantees that blockchain provides around like longevity of the services. And then the other part was always that, yeah, API kind of syntactic kind of language was limited. And so like, but I wonder it's this way, right? Now you need somebody to go and add another API versus again, like now with the semantic, again, to me, agents and APIs is the same thing. It's just like transitioning from syntactic space to semantic space. And so, so now you can actually interact with them in semantic space. You don't need to like ask every time a development team to add a new API to the same, potential data sources or the same type of functionality. So I think
we actually are.
Yeah, go ahead.
Yeah, so we actually already see this trend in one of our partners. In this case, they actually want to create doubles for the creator, and then they did some research that if they have a double for creator and answer their fans' questions, the revenue can 3 times with comparing to a creator without their double. In this case, so we are building a use case with them to we cannot disclose it yet, but we are building a use case with them to say this is like a empower the creator to actually create a double, answer the question from their fans.
Yeah, I think we're over time, so I wanted to thank you for the convo. Thanks for coming. I hope the audience enjoyed this conversation. There's obviously still a lot to figure out and work out as we're developing the space, but I think we have amazing people across the board to do this. So I'm sure there will be a lot of progress in coming months.
Thank you so much hosting us, Illia and Alex. Really enjoyed the conversation.